Hi guys, welcome back to my YouTube channel. Today in this video, I am going to discuss a new chapter in image processing. These are the topics these are the topics in unit 2 we are going to discuss. So let us discuss each topic one by one. The first topic in the unit 2 is image enhancement in spectral domain point processing. This is the first topic. First let us know the what is image enhancement. Basically, image enhancement is a process of making images for more useful. Means, let us take an example as black and white images. In olden days, they used to click the black and white images only, but in modern days, the technology is developed. We are taking the colorful images. Means difference between these two images means that image will be in black and white. This image will be in the colorful with multiple colors, so that we are recreating by using some functions or the some technologies, techniques, etc. We are recreating that image by giving brightness or removing noise from the data, noise from nothing but a unwanted disturbance or unwanted things, like something race, like example, that we are removing from that image. This process, whole process, is known as image enhancement. Image enhancement is the process of making images more useful, such as making images more visual appealing, brightening out specific features, and removing noise from the data and highlighting interesting things or interesting details in the images. This thing is known as image enhancement. Next, coming, so this is an diagram of the image enhancement techniques. We are taking the input as a image. Next, we are applying the some application specific, like we are applying some functions or the techniques to that image, and finally output better image. See, let us see this example. In this figure, we are having the two figures, like the first figure is, it is dull and it is unclear. We cannot, the pixels of the image is unclear. It is not in HD format. It is basically that pixel of the image is unclear and it is dull. Next, compare it to second image, compared to first image, the second image is more clear and it is in HD format. That's why this process is known as image enhancement. This, we are applying the input and we are giving some algorithms or some techniques to this image. After that applying, we are getting the better image compared to the first image. This is known as an image enhancement. In exam, you have to define this diagram. In the definition of the image enhancement, you may ask for 2 marks or 1 marks for what is image enhancement. And next, coming to next topic, that is spatial domain techniques. This spatial domain technique is divided into sub techniques, that is point operation and spatial filters, or mask filters or kernel filters. This point operations means nothing but this operation involves applying some transformation to each pixel in a grayscale image based on its original pixel value and independent of its location or neighborhood pixels. We will learn about more things in point operations. We are having different types of operations. In that operations, we will discuss deeply about point operations, intensive intensity transformation. The another name of the point operation is intensity transformation. Point operation means nothing but we are applying the extra pixels to that image, and bringing the, comparing to the old image, we are bring in output we are getting the clarity image, brightness, brightened image, and the colorful image. Basically, this image processing means nothing but a comparing to input. In output, we are getting the uh, clarity image, colorful image, brightened image, etc. We are taking input as a dull image. In output, by applying some functions or algorithm, we are getting the brightened image, colorful image, and we are removing all the unclear data from it, and we are taking the cleared data. In point operation, we are applying the pixel values to that image, and in output it is generating the cleared image by using that pixels. In spatial filters or mask or kernel filters, we in this we are giving the functions like dependency values like x-axis function, y-axis functions to that image for the processing of the output. It will take the input, and we are applying to that input for that functions like x-axis and y-axis. It will generate and output will be generated. These are the two techniques. Next, applications of image enhancement. We are having the applications that we are where the image enhancement is used. These are the some applications that we are using image enhancement. First one is de-blurring images. De-blurring images means nothing but for improving the clarity of the image, we are using this de-blurring images. Next, to contrast adjustment. For contrast adjustment means for image enhance image detail visibility. For visibility means it is also category of clarity only in HD format. Visuality means eye contact. It should be more clear than de-blurring images. That is known as contrast adjustment. Next, image brightening. Image brightening means lightness of the image, bringing the light. If we are clicking or taking the image in the night time, there will be some low light in the night. For that images, we are bringing the brightness to the images. That is known as image brightening. Next, image smoothing and sharpening. These all categories comes for editing the images. Next, noise removal means nothing but uh, editing the pixel of the image. Next, size of the images. If we are having the unwanted data in the images, next we are deleting that unwanted data is known as noise. Next, grayscale image histogram evaluation. In these applications also, we in these all applications we are using the image enhancement. Enhancement is image enhancement plays a major role in these all operations or in these all applications. Next, we are having the two techniques for image enhancement, that is spatial domain and frequency domain. Spatial domain is also having two operations, that is point operation, spatial filters. Let us discuss each operations or each techniques one by one. Spatial and frequency domain. Spatial domain techniques manipulates the pixel of the image directly. This process happens in the image coordination system is known as spatial domain. Spatial domain is nothing but we are giving the pixel to that image directly. Means we are giving the value to that image like in the format of pixels. If we are giving the directly to the pixels to the image, that is known as spectral domain is known as this process whole process is known as spectral domain. Whereas frequency domain techniques transfers the image from the spectral domain to the frequency domain. After completing the spectral domain, if we are applying the pixels to the spectral domain, next this output is transferred to the frequency domain. In this process, we are giving the mathematical transformations like Fourier transformations like x-axis, y-axis, and giving some logarithms techniques to that image for more attraction or the brightness to bring the clear image. We are giving this mathematical transformation. In this frequency domain, we are giving the mathematical transformation. This image can be this type of images can be modified and manipulated is known as frequency domain. Basically, in spatial domain, we are giving the pixel to the image. It will convert basic image into pixel image. Next, that pixel image is given input to the frequency domain. In frequency domain we are applying the mathematical transformations like Fourier transformations, like logarithm functions and mathematical functions, that all x-axis and y-axis to the image, that all modifications and manipulations are done in the frequency domain. Next, this is the diagrammatical representation of spatial domain enhancement operations. We are selecting area of the image, some part of the area in the image. We are giving the x-axis and x-axis and y-axis. We are selecting some part to edit the image, that is x and y. Most spatial domain enhancement operations can be reduced to in the form of we are giving one formula, that is g of x comma y. Means we can take anything. G is nothing by here. G means image. It is an input to the image, is equals to t of f of x comma y, where f is equals to x comma y is the input image. This is the input image. And next, g of x comma y is the processed image, and t is some operator defined over some neighborhood of x comma y. We have to write this formula and this sentence in the spectral domain enhancement. By writing this formula, you can get the out of marks. G of x comma y is a processed image. F of x comma y is a generate input image. We are taking one input. After processing the input, we are getting the output, that is g of x comma y. X comma y is a neighborhood, means x axis, y axis, z axis, all the neighbors is known as x comma y. And coming to the point process techniques, when the neighborhood is pixel is itself, simplest spatial domain operation occurs. Point processing operations takes the form s is equals to capital T of r, where s refers to the processed image pixel value and r refers to the original image pixel value. Here we see the formula. In point process techniques, we are having the neighborhood. When the image is having the neighborhood pixels means nothing but a point. So we are giving the size of the image in the pixel format, right? That is known as point processing techniques. It is having the point it is have if, when the image is having the pixels by itself, then it is known as point process techniques. In point process techniques, we are having the different types of functions. For all these functions, we are using this formula on s is equals to capital T of r, where S is the processed image and R is the original image. First one is a negative image. Negative image. Let us see the original image first. It is having more brightness and somewhat it is an darkest image. After we are applying the formula, that is intensity marks, S is equals to intensity mask R. We are giving this formula S is equals to 1.0 minus R. This is the formula to we are applying to this image. Next, we are generating the negative image. Means it is a type of X-ray. We can take example as X-ray image. Negative images are useful for enhancing details. We can see the clear cut image where the we have now we compare the original image and negative image. We can see the black lines clearly compared to the original image. In a negative image, we can see the black lines clearly, that is the negative image. Negative image means nothing but a x-ray is a negative image only. Example for the negative image is x-ray. Next, thresholding means in thresholding all the transformations may done. In background, all the transformations will done by the, we are taking the low image constructions, and the intensity values will be more. Threshold transformations are useful for segmentation, in which we can want to isolate an object of interest from the background. If the threshold is too low, image contains higher intensity values more. If the threshold is low, image contains higher intensity values. If the threshold is too high, image contains lower intensity values. These points are very important to define the threshold. Let us see in the diagrammatical way. Here we are taking the input image, we are applying the threshold values for this, where r is equals to low and r is equals to high. Means r is nothing but here threshold. Threshold values is greater and threshold value is lesser or equal to, it will be generated in this type of format. Compared to it generating the black and white images only, we can see the difference between original image and the generated image. Next, third one is sum of the gray level transformation. In these transformations, in or in these functions, we are having the uh, different types of functions like linear, logarithm and power n. This is the diagrammatic representation of gray level transformations. In this gray level transformation also, we are having different types of gray level. This is used to compare the image. This diagram is useful to compare the image. In this, we are having all the logarithms and powers, inverse log, we are all using all different types of transformations. All mathematical functions and mathematical logics are all implemented in gray level transformations. One of the transformation of gray level is logarithm transformation. In this logarithm transformation, we are having the logarithm functions. S is equals to c into log of 1 plus r. This formula is implemented for logarithm transformation. The logarithm transformation maps a narrow range of low input gray level values into wider range of output values. The logarithm transformation is used for narrow range of low input to generate a wider range of output. For that type of images, we are using the logarithm transformation. The inverse log transformation performs the opposite transformation. While using the inverse log transformations, it will generate the opposite transformation for the inverse log. Log functions are particularly useful for input gray level values that may have an exactly large range of values. Let us see an example in the image format. That is, an original image is having very dim and small light is in that image. After applying the formula s is equals to log of 1 plus r to that image, we can see the image, generated image. We can see the differences of the original image and generated image. This is known as logarithm transformation. Next, power law, gamma correction or power law is same. Gamma correction transformation. In this gamma correction transformation, we are using the formula that is s is equals to c into r gamma. It is useful to map the darkest spot in the image, and it will generate the output in the larger values. Wherein gamma gives a whole family of curves, means we are selecting the darkest input. In the image, we are selecting the darkest input for the gamma corrections. This is the diagrammatical representation of the gamma corrections. This is a image that is useful for equation s is equals to c r gamma. For various values of gamma, s is equals to 1 in all cases. All curves were scaled to fit in the large in the shown range. These are the values for we are using gamma. That is, gamma is equals to 0.4, 0.10, 0.20, 0.40. In horizontal we are have in x axis we are giving the gray levels. In output in y axis we are giving the output gray level. Next, these are the image examples we are taken. See, we are giving the, this is an first image is an original image. That for that image we are applying the gamma gamma range, that is 3.0. For the 3.0 we are generating this type of images. Next, for 4.0 gamma range or r range is equals to 4.0. For that we are generating somewhat lighter than compared to 3.0. Next, s range is 5.0. This type of images, this darkest, the compared to original image, the generated images is darker or more brighter. Next, gamma corrections. In gamma corrections we are taking this type darker part of the gamma correction, we are monitoring that. Next, we are getting more darker compared to the original image. First image, we are taking second image also with darker spot, we are monitoring that image or applying some functions and getting the darkest part. Next, piecewise linear transformation functions. Piecewise means nothing but if we are having one image that is covered by another layer, the image is unclear, so we are using this piecewise linear transformation function. For the we are generating that one curve. After that processing we are getting this type of image formatting, clear image. We are removing that layer, upper layer of the image, and generating the clear image for the original image. You have to represent this diagram format also in examination, this box like functions, and you have to display this line or curve. This level gray input gray level diagram should be displayed in the examination paper. Next, gray level slicing. Slicing means nothing but a cutting. Highlights of the special range of gray levels or other levels can be supervised or maintained. Suppressed or maintained means we are deleting the unwanted data. Slicing means removing the unwanted information or unwanted data in the images. We can see this line is generated, and two objects are displayed in the original image compared to uh, generated image. The in upper side one object is removed or one line is removed, so that is unwanted image in the original image, so we are removing, we are slicing, that is known as gray level slicing. Next, image enhancement. In image enhancement we are having different types of images, we are using different types of images, that is dark image, brighter image, low contrast image, and high contrast image. If the images are unclear, so please comment me for the more data or the for more images. I will sharing you the notes of this topic, and I will be sharing the images. These type of all images are useful for image enhancement. So these are the topics that we have covered today. I hope you have understand this video, so please like, share, and subscribe.